All right, so we've talked about the graphs of these quadratic functions that I've got sketched up here. So I'll use sort of y and f of x interchangeably, so be prepared to see either y equals one of these things or f of x equals the same. It applies the same way one way or another. So we've talked about f of x equals ax squared plus bx plus c. We've looked at the graphs of these things. We call them parabolas. And in particular, we spent a lot of time talking about sort of that turning point, the peak and or valley of the quadratic, parabola graph, what we call the vertex of the parabola that we ended up getting. So in the video where I was doing all the Desmos stuff, you could take a look at it and see that, it was there because Desmos handily flags stuff like that out. Now, what if it turns out, your internet goes out and you don't have Desmos, or your batteries fail in your calculator or whatever, and you needed to sketch a graph of one of these things by hand, or you needed to identify the vertex of a parabola for like an application, but you don't really need to go to all the trouble to sketch the graph. It turns out the formula that is supplied for the quadratic function gives you everything you need to identify where the vertex is. We've already seen that we know whether it's a maximum or a minimum, whether the parabola is opening up or down, just based on whether this leading A is positive or negative. So, what about the vertex? So, as it turns out, it's not super duper hard. I don't actually think this is as challenging as working through the quadratic formula or some of the factoring stuff when we were tracking down X-Intercepts or trying to solve the quadratic equations in the previous section. So as it turns out, the x-coordinate of your vertex, you can just rip almost straight out of this thing. It's just a little bit of arithmetic that you'll need to adjust. So the coordinate of the vertex, or the x-coordinate of the vertex, is simply negative b over 2a. Do note that minus sign out front. That's particularly important. So that's the x-coordinate of our vertex. The y-coordinate, all you really need to do is take this x value and plug it back in here. I wouldn't do it with the general formula because that's going to be kind of scary looking when you see all of the a's and b's and whatnot flying around. But it's not too tough to write it out like that. Just plug the x-coordinate you come up with, which in your examples is going to be a number. Just plug the number back into that guy. So I'm looking at one of our examples from the from the sketches. So we had this guy. So we had y equals negative x squared plus 9x. So in this instance, our a is negative 1. You can fill out, because we got that minus right there. The b is 9. Technically, the c is 0. There's no constant term, but, that's fine. All right. So now that we know a and b, we can just feed those values into this formula right here. So we get negative b, 9 over 2 times negative 1. And you work out the arithmetic here. You get positive 9 halves, because you have a negative and a negative. They cancel. But so 9 halves. And if you like that as a decimal, the 4.5, so that matches up with what you saw in the Desmos graph in the previous video. The x-coordinate of the vertex for this fella was, in fact, 4.5. So now we've got the x-coordinate, and we can tell that in this instance, the x-coordinate is a maximum because that parabola is opening downward. So when we hit the vertex, that is, in fact, a peak. So now, to get the y-coordinate, we just need to take this guy and plug it in to the function. So negative 9 halves squared plus 9 times 9 halves. And you can work through the arithmetic here. Like I said, I'm comfortable with fractions. So I'm perfectly fine with saying this is negative 81 over 4 plus 81 over 2. As it turns out, as a fraction, you'd get 81 over 4 when you work out the arithmetic. If you like decimals, it's perfectly fine. If you had plugged in the 4.5, it'll work out just fine. And you'll get 20.25. So now we have the coordinates of our vertex. If we wanted to write it as an ordered pair, parentheses, 4.5, or 9/2, whichever one you want, comma, y-coordinate, again, as a fraction, 81/4, as a decimal, 20.25. There's our vertex. We know it's a maximum because our leading coefficient is negative. All right, so let's take a look at that other example and identify its vertex and see what's going on here. So, in the other example we had, y equals x squared plus 4x plus 4. So again, a is 1, my b is 4. I'll identify the c, but I don't actually need it for the vertex. So I've got my a, my b, and my c. So now we just repeat the process. Fill in the blanks. Negative b, 4, over 2 times a, which is 1. So negative 4 divided by 2, that gives us negative 2. Should have put a box around my answers here as well, but there we go. So that way you know where the coordinates of the vertex are. So once I've got my x coordinate, I can plug those in to my formula to get my y coordinate. And again, this is just confirming what we've already seen in the graph, right? So we work out the arithmetic here. Negative 2 squared is 4. We're going to get a minus 8 out of this guy, plus 4. Lo and behold, our vertex really is sitting at negative 2, 0, like we saw where the vertex was just kind of touching down on the x-axis there. So yeah, that's that. And I mentioned this in the video. I'm not going to belabor the point because we did a lot of this in section 2.1 already. So just as a quick aside, so if we want to find our x-intercepts, again, I talked through this while we had the Desmos graphs up, but the idea is at an x-intercept, your y-coordinate has to be 0 because there's no change vertically speaking. And then you'll have a quadratic equation where you've got something like this guy here, x squared plus 4x plus 4 equals 0, or negative x squared plus 9x equals 0, and then using either factorization or the quadratic formula, you can work out what's going to happen with your, as you said, with your x-intercepts, get the x coordinates. The y-intercept is the same way. You set x equal to 0, but usually y-intercepts don't give people too much difficulty because you don't really need anything fancy. Plugging zeros into this guy, he just vanishes and you're left with y equals 4. Over there, you get y equals 0 when you plug in x equals 0. All right, so I've got one more, a couple more examples here. One example of this in action and then kind of a different topic, but we'll get to that in just a sec. Let me clear off some board space. All right. Okay. So the next example listed in the Moodle Notes file talks about a profit function. So yeah, we're going to end up seeing this in applications moving forward. Hopefully that's not too much of a spoiler for you. So we have p of x equals negative. I'm going to put in the 0. I don't require that you write them in general, neither does WebAssign or a calculator or anything, but I'm bad about losing the decimal point if I don't. So yeah, 0.2, x squared, negative 0.2 x squared, plus 150x minus 600. So we're asked to find the maximum profit and the production level that will get us that maximum profit. So when you see applications that talk about a maximum and you've got a quadratic function sitting around, the basic idea is this is an exercise in vertex hunting. So that's really all we need to do. There's not a lot of additional machinery here. We just work out the x and the x and p of x values for our vertex. So yeah, when you're trying to track down a maximum, and again, you can figure out whether it's a max or a min based on the leading coefficient here. It's going to be a maximum here because my a value is in fact negative. So I've got my a, my b, and my c in this instance, and we can work out the production level technically comes first because that's our x coordinate. So let's work that guy out. So x equals, I'll write out the formula just as a reminder, negative b over 2a. I can fill in the values. So I have negative 150 for b over 2 times negative 0.2 down below. So the negatives will cancel like they did with that first guy we took a look at. And if you work out the arithmetic here, 150 divided by 0.4, you should end up getting 375. That was what I came up with. So our production level, we're going to have to produce 375 of whatever it is this company makes in order to maximize our profits. So that's our production level. So that's our production level. So to get that maximum profit, now it's like finding the y coordinate of our vertex. We just plug our production value of 375 back into this thing. So just like we saw in chapter 1, everywhere we see an x, we feed in 375, and then we pound through the arithmetic. This is not the sort of thing I would necessarily expect you to do by hand, but when I worked this out, I'm not going to show you all of the stuff I wrote up. You'll get the idea, I think. We have $27,525. So that's where our profit level maxes out. This finally seems like a number that's a little more reasonable than some of the other stuff we've come up with. So we need to make 375 of whatever it is, and we need to sell, as you're saying, that's how much money we're going to have when we're done. All right. So the last thing I want to talk about in this section is this notion of average rate of change. We saw a formula that looked kind of like this guy when we talked about slope. If you replace the function values with y's, that's what it kind of ends up looking like. So that's this formula is given for average rate of change. Change in function value over the total change in x that occurs. So we've got in this instance, we're looking at one of our example quadratics from earlier. So what is it? It goes from x equals 2 to x equals 6. So for this particular example, as we pound this thing out, we just plug, this is going to be my a. The smaller value would be a. The larger value would be b. So we have f of 6 minus f of 2 over 6 minus 2. You can work out the arithmetic here when you plug x equals 6 into this thing. I got 64. When I plugged in 2, I got 16. So we have 64 minus 16. 6 minus 2 down below gives me a 4. 64 minus 16 is 48. 48 divided by 4 is 12. And so that's my average rate of change. It's not quite like a slope because this isn't a line, so we don't really have a slope to talk about. But that gives you kind of the idea of measuring over a particular interval of x values, how much did your y value end up changing, per unit. It's an average, it's an estimate in this instance, but it still ends up being useful in some applications. Speaking of applications, the next section, just like we saw in chapter 1, is all about them. So keep watching.